Hello, I'm Verna Phillips, and I'm going to be talking to you about Math 121. Okay, this is Math 121 at Southern West Virginia Community College, and it's taught on the Williamson campus and the Logan campuses. We started the semester out by talking about patterns, number patterns. Okay, and there's different types of number patterns. Okay, you have 1, 4, 7, 10, ... Now, if you look at that, you should be able to predict the next pattern. Okay, this every time you add 3 to the number, so we can predict the next number. And 1, 4, 7, 10, 13, and 16, and it goes on and on and on. Okay, every time you add 3 to it, a number. Now you could have added 5 to every number. You could have added 10 to every number. You could have added 7 to every number. You could have added 2 to every number. Anytime you increase the previous number by a certain number, it's called an arithmetic sequence. Okay, you keep on increasing the number patterns by 3 every single time. Okay, so also there's other kinds of sequences. Okay, we could have sequences of numbers like 1, 1, 2, 3, 5, 8. And we've talked about this in class. And if you notice, you look at that, and you add the previous two terms together to get the next number. 1 and 1's 2, 2 and 1's 3, 3 and 2's 5, 5 and 3's 8. And the next number will be 13. And the number after that is 21. Okay, so you add the previous two terms together. If you do that, you have what's called a Fibonacci sequence. Okay, and there's different kinds of Fibonacci sequences. Okay, you could also have 1, 2, and then 3, 5, 8, 13, and that's another kind of Fibonacci sequence. Or I could have 1, 6, 7, 13, 20, and we can predict the next number. Okay, so that's a Fibonacci sequence. Fibonacci sequence. And a third type of sequence is called a geometric sequence. Okay, you multiply 3 times 1 is 3, 3 times 2 is 3, okay, or you can multiply every number by 3, right? 3 times 1 is 3, 3 times 3 is 9, 9 times 3 is 27, and then you can predict the next number. This is called a geometric sequence. So, and there's other sequences too that doesn't really have a pattern. I mean, have a name. Let's say you have 1, 0, 1, 0, 0, 2, 0, 0, 0. And then you get the next number. Okay, or you could have 1, 5, and then you could have 9, and then 13, and then 13 and 9 is 22, and you predict the next term. So this one right here does not have a name, the top one. This is no name. And this one is a arithmetic sequence. Okay, now another topic we've talked about in this class is we talked about sets. What is a set and what is not a set? Okay, set concepts. Okay, now a set is a collection of objects. Collection of objects. And those objects are called members or elements. And there's different ways of listing members of sets. Ways to list members of sets. There are 3 ways to list members of sets. One is called set builder notation. Another way is verbal description. And then the roster method. Okay, the roster method is the method that's most common. Okay, the roster method is just simply listing elements of sets with commas between them and braces enclosing each set. Okay, now what if we want to write set of whole numbers which are multiples of 4 greater than zero and less than 50. Okay, set of whole numbers which are multiples of 4 greater than 0 and less than 50. Okay, now your whole numbers are 0, 1, 2, 3, 4, ... Okay, there's no decimals, no fractions, no negative numbers, just 0, 1, 2, 3, 4, ... Okay, the set of whole numbers greater than 0 and less than 50 will be 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Okay, the whole numbers. Now these are your whole numbers. Okay, no decimals, no fractions, no negative numbers. Okay, that's called the whole numbers. Okay, now what if you have, you're given the set of elements B such that X, the set of elements X, such that X is an element of the natural numbers and X is even. Okay, and natural numbers is just another way of saying whole numbers. Natural numbers and whole numbers is the same thing. Okay, so all the even numbers are 2, 4, 6, 8, 10, dot, 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 dot. Okay, meaning they never end. Okay, this is the roster method. And this little E right here, it means is an element of. This is the roster method. Now let's determine whether these statements are true or false. Three is, that means is an element of the set 3, 4, 5. Is that true? Okay, is the number 3 an element of the set 3, 4, 5? That is true. Okay, is the set 3 an element of the set 3, 4, 5? That is false. Okay, is the number 3 an element of the set which has the set 3, the set 4, the set 5? Is an element of this set which has the elements 3, 4, 5? That is true. Is the set 3 a subset of the set 3, 4, 5? Okay, this symbol right here is subset. That is true. Okay, to be a subset, it has to be a set itself and has to be part of that set. So it is true. We've gone over subsets in class. Okay. Okay, now we're going to talk about number of subsets. Okay, a set has, let's say, 1, 2, 3. The number of subsets, subsets will be the empty set, the set 1, the set 2, the set 3. And you also have the set 1, 2, the set 1, 3, the set 2, 3, and the original set itself. Okay, that's 8 subsets. Set with 3 elements in it has 8 subsets. Now we're going to talk about Venn diagrams and set operations. Okay, Now, this symbol is a symbol for intersect. This symbol is a symbol for union. Okay, now the universal set is a set of elements under discussion, and all the other sets underneath that are going to be subsets of that set. So the set U in this problem is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The set A has 1, 2, 3, 8. The set B has 1, 3, 6, 7, 8. And the set C is 1, 2, 8, 9, 10. Okay, 1, 2, 8, 9, 10 is set C. Okay, C is 1, 2, 8, 9, 10. And we have A as 1, 2, 3, 8. Set B has 1, 3, 6, 7, 8. Okay, find A intersect B. A and B share what elements? They both have 1, and both have 3, and both have 8. So A intersect B is 1, 3, 8. And A intersect C is what? A and C both have 1, 2, and 8. Now A prime intersect B is what? So C was 1, 2, 8, 9, 10. A has 1, 2, 3, 8. B has 1, 3, 6, 7, 8. And of course U is 1 through 10. So let's find A prime intersect B. Okay, A prime, if you take 1, 2, 3, 8 out of U, what will you have left? 1, 2, 3, 8. Okay, that will leave me with 4, 5, 6, 7, 9, 10. And what is that with intersect B? B both has what? 6 and 7. Now we're going to talk about union of sets. Union of sets is this symbol. That means all the elements in one set, all the elements in the other set put together into one set. So let's say U has elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A is 1, 2, 4, 6. B is 1, 3, 6, 7, 9. And C is 158. Okay, let's find A union B. C is 158, and U, of course, is 1 through 10. A is 1, 2, 4, 6. B is 1, 3, 6, 7, 9. A union B is all of A and all of B put together into one set, which is what? 1, 2, 3, 4, 6, 7, 9. And A union C is what? All of A and all of C put into one set was what? 1, 2, 4, 5, 6, 8. Okay, so that's union. We did union and we did intersection. Okay, now the results of a survey at the Grand Canyon showed that 25 speak Spanish, 14 speak French, and 4 speak French and Spanish. Now, how many speak French or Spanish? Okay, the number of people who speak French or Spanish, okay, is the number of people who speak French plus the number of people who speak Spanish minus the number of people who speak French and Spanish. So how many speak French? 14. And the number that speak Spanish is 25. And the number speak both? 4. So 14 and 25 is 39, minus 4 is 35. So 35 speaks French or Spanish. Now, this is a diagram we use later on in the class. I haven't introduced it yet, but you could also do this, in this class until now, we could also do this with a Venn diagram. Let me draw the circle darker. Okay, this is people who speak French. And here's people who speak Spanish. Okay, the number of people who speak both languages is 4. Okay, the total number who speak French is 14. So the number of people who speak only French is 10. And 25 speak Spanish, so 21 speak Spanish only. 21 4 is 25 and 10 is 35. Okay, and there's, well, you don't know how many were actually surveyed altogether, but so we don't know how many people didn't speak either one. Okay, so that's the number of people who speak French or Spanish, and that's using the Venn diagram. Okay, all right, Liberty Travel surveyed 125 customers. Okay, 68 wished to travel to Hawaii. $53 wished to travel to Las Vegas. I put 58. I meant 53. 53. And 47 wished to travel to Disney World. Okay, now 34 wished to travel to Hawaii. And Las Vegas. And 26 wished to travel to Las Vegas and Disney World. $23 wish to travel to Hawaii and Disney World. And 14 wish to travel to all three. All right, now the question is, how many did not want to go to any place at these places? Okay, now we have to draw a Venn diagram to answer these questions. Okay, so here's how many traveled to Hawaii. Here's how many traveled to Las Vegas. And here's how many wanted to travel to Disney World. Now, excuse me just a minute. Oh, here it is. I was going to say I need to find my calculator. Okay, now, 16 wanted to travel to all three places. And then 23 wish to travel to Hawaii and Disney World. So 23 minus 16 is 7. 7 traveled only to Hawaii and Disney World. And 26 to Las Vegas and Disney World. So 26 minus 18 is 8. And 34 wish to travel to Hawaii and Las Vegas. So that's 34 minus 16, which is 18. Okay, 18 traveled there. And then the number that traveled to Hawaii is 68. 18 plus 16 plus 7 is 41. 68 minus 41 is 27 to travel to Hawaii only. And Las Vegas is 53, so 16 plus 8 plus 18 is 42. 53 minus 42 is 11. And Disney World, 47 traveled to Disney World, so 7 plus 16 plus 8 is 31. 47 minus 31 is 16. Okay, 16. Now, how many didn't travel to any of these places? There's 125 people surveyed. So 27 plus 18 plus 11 plus 7 plus 16 plus 8 plus 16 is 103. 125 minus 103 is 22. So 22 didn't travel to any of those places. Okay, so I hope this will help you study for your test for my class. Okay, I hope you enjoyed this video. We're gonna work another problem before I close the session out, though. Okay, but anyway, if you have any questions on this, please let me know. Does A intersect B union C equal A intersect B union C? And you have to use a Venn diagram to find that answer. Okay, B union C is what? 2, 3, 4, 5, 6, 7. And A is 1, 2, 4, 5. So A intersect B union C is 2, 4, 5. Now that's the left hand side. Let's do the other side. Remember, this is 2, 4, 5. Okay? With the left hand side, A intersect B union C came out to be 2, 4, 5. Now what does A intersect B union C equal? and B meet, and you have 2, 5. And C is 4, 5, 6, 7. And A intersect B union C is 2, 4, 5, 6, 7. So the original question was, do they equal? And they do not, because the right hand side is 2, 4, 5, 6, 7. The left hand side is 2, 4, 5. So they are not equal. And I really hope you enjoyed this video. This is a kind of review for your test. We'll do more reviewing in class, but I was hoping you could watch all this and get, maybe if you had any questions or there's something you didn't understand, maybe this cleared it up. And if not, please come and talk to me on anything you don't understand. Okay, I'll close this out, and I hope you learned something from this class. I'll talk to you later. Bye-bye.